Hello, welcome, there is Zmotion technology. Let's continue our motion control quick start learning. How to develop our motion controller. Lesson 17 now, related contents of motion controller interpolation. If you are the very beginner, you could review former videos. About the interpolation, there are many types. Therefore, it will be described from 3 parts. Part 1, Interpolation Principle and Basic Interpolations. Part 2, Interpolations Feature Look Ahead. Part 3, Interpolations Feature Self-Defined Speed SP. And it can be seen corresponding commands all are here. Also, they will be talked one by one, including examples. Today, start the first part. What is interpolation, and how to achieve needed interpolation motion? Interpolation is used to do data calculation according to given information. And it is one real-time data densification process. That is, it will calculate each interpolation coordinate axis feed commands. And drive each execution part to do motion. Then, the controlled mechanical parts will move an ideal path and at suitable speed. In a short, the interpolation is one process that confirms the tool motion trajectory. It needs 2 axes at least. Map the planning axis to corresponding coordinate system. Then, according to the coordinate mapping relation, the controller can control each axis motion to achieve required trajectory. Please note interpolation motion commands are saved into motion buffer at first. Therefore, the motion is executed through getting commands from buffer. Until all commands are taken, the interpolation also ends. There are many types of interpolations. Among them, linear interpolation and circular interpolation are used commonly. Let's see one by one. Linear interpolation. It will move one motion that looks like the straight line. Specifically, give one pulse value to the axis. Then, the motor will move corresponding distance. The distance is not general, depending on your motor. And in real application, one pulse is not enough, because the motion will be very slight. Sometimes, 10,000 or 100,000 pulses can make the motor rotate one circle. Please set it according to real situation. After it arrived the pulse distance, it will compare the point with the real contour. If it is below the real contour, move towards Y direction. If it is above the real contour, move along with X still. Follow this rule all the time, until it reaches the end point. Please see this graphic. It shows the whole process. See, it is lower than the real contour, so it moves in Y direction. But for this, it is still higher, so still moves in X. Even though it is made by several polylines. The interpolation precision is very small, within one pulse. The trajectory will be smooth enough, so it is almost one line. Maybe you are confused how it calculates. The core calculation formula is Pythagorean theorem. For example, move A to B, the distance x can be obtained easily. Then, while moving, it will check coordinates situation. In this way, needed trajectory can be achieved. However, these 2 axis speeds are not same. For interpolation motion, it takes main axis parameter. The main axis is our first axis in base parameter. So, here, the interpolation speed is axis 0 speed. If you want to know real speeds of axis 0 and axis 1, calculate by this. Okay, this is linear interpolation. Circular interpolation. Same principle as linear interpolation. According to given coordinates, move one circular motion. Also, see this graphic. It is lower, move in Y. It is upper, move in X. This shows plain circular interpolation. 2 axes are enough, X and Y. But if you want to move a space arc, please give information of 3 axes, X, Y, and Z. And space arc can be drawn according to 3-point or center. That is, coordinates should include current point, end point, middle point, or arc center. Okay, now, we have known the basic interpolation principle. Next, let's corresponding commands. Use move to do linear interpolation. Use moveCirc to do circular interpolation. and enter corresponding parameters. They belong to relative motion commands. That is, the distance is relative to current interpolation point. If you want one absolute motion, which is related to origin point, just add the ABS suffix. If you want to make it move at specific speed, not the spindle axis speed, just add the SP suffix. There are 3 types of speed commands. Obviously, starting speed, motion speed, and the end speed. Here, we mainly talk about and show relative motions for you. Move, it can do single-axis motion and multi-axis linear interpolation motion. You only need to fill in distance. For interpolation, mentioned before, it uses the main axis parameters configurations. Including the buffer, it is saved into spindle buffer area. This is one example. There are 6 linear motions. And it can be seen its starting point is not 0, 0, but the 100, 0. Offset it to 100, 0 at first. First motion, it will move left 50 in X, and move up in Y. Second motion, it will move left 100 in X from the endpoint of motion 1. Following 4 motions are done according to set parameters in move. Then, 2 axes will move 1 hexagon. This is relative motion. To achieve absolute motion, please use moveAbs command. And the parameters are totally different. First one becomes moveAbs, 50, 100. Which means it moves one absolute distance from 0, 0. Next, circular interpolation, there are 2 modes. Mode 1, moveAcirc, drawing the arc by starting point, endpoint, and the circle center. You need to enter coordinates of endpoint, circle center, and the direction. Mode 2, moveAcirc 2, drawing by the current point, not the center. But for this, one single command can't draw one full circle. Also, enter corresponding parameters. Same, see the example. According to these codes, 2 arc motions are needed. First arc, it will move to 100, 0. Center circle is 50, 0. So, the arc radius is 50. And draw it in clockwise direction. Then, its real motion is this one. Second arc, the radius becomes 100, still clockwise. The endpoint filled is minus 200, 0. Then, move 200 from 100, 0. Because it is relative motion. The real end is minus 100, 0. If absolute motion, commands will be these. Except linear interpolation and circular interpolation. There are many others. Let's continue. Do spiral interpolation according to the circle center. It is one 3-axis relative interpolation motion command. Use this and enter these parameters. It can be seen the first axis and the second axis execute the circular interpolation. For the third axis, it will do spiral motion. You only need to enter the distance. Sometimes, if you want the last axis to be included in interpolation speed calculation, set the mode as 0 or not set. Generally mode 0 is default. Through this command, axes can make one complete spiral. And it is a full circle from the Z direction. See the example and the effect graphic. Axis 0 and axis 1 draw the arc in clockwise. From 0, 0 to 200, 200. Axis 2 moves 100, participating speed calculation. After that, the trajectory is this. From Z direction, it is one circle. Next, ellipse interpolation. Similar to spiral motion. The former 2 axes do ellipse interpolation. Then, set the last axis, whether to do spiral interpolation. Therefore, accept these 5 same parameters. The 2 axes ellipse radius are needed. Radius of semi-major axis or semi-minor axis. And when they are same, it will be an arc or spiral automatically. The last one is the third axis motion distance. If the value is set, the third axis will do spiral motion. Through this command, one full ellipse can be drawn. But the ellipse is perpendicular to or parallel to the X. See this configuration. Starting point and end point are the origin, which means it is one complete circle. The center is here. Semi-major axis distance is 100, minor axis distance is 50. And the direction clockwise. So, it is drawn like this. Obviously, no spiral motion of the last axis. If spiral motion is set, and the distance is 200, command becomes this one. One ellipse is made still. But if you see it from left, one spiral of 200. Circular interpolation was shown just now. If three axes do arcade, actually it is space arc motion. Same, use center or middle point to draw the arc. If by circle center, please enter center's coordinates here. If by the middle point, enter the coordinates. The other important parameter is mode. There are 4 modes. Mode 0 and Mode 1 draw one arc. Mode 2 and Mode 3 draw one complete circle. And it can be seen Mode 0 and Mode 2 use middle point. But for Mode 1 and Mode 3, they use circle center. For these two are for spiral. Same as before. See examples one by one. Mode 0, draw the arc by current point, middle point, and end point. It will be like this. Mode 1, draw the arc by circle center. And choose the shortest distance, like this. Mode 2 and Mode 3, similar to former two modes. They draw the complete arc automatically. The last type, involute arc interpolation. This only can be relative motion and SP motion, no absolute type. It draws the involute arc. Parameters are circle center coordinates, circle numbers, pitch distance. If you want one spiral, please set distance for third axis and fourth axis. Except these, for involute, it needs one starting radius, which is calculated by the distance from current point to circle center. When it is 0, no angle here, angle 0. Like the example 1. Start from the origin. It moves 2.5 circles in anticlockwise, and each circle space is 30. First circle. Because now center, starting point, and end point are in the same line. Second circle. And the last half circle. If you want it to move in clockwise, set the circles as negative value. If the spiral is added, it will be like this. Move up 100 in axis Z. Let's see real operation in RT-Sys. Open the RT-Sys. Then copy the involute interpolation codes here directly. Set the auto-run number. Connect to controller or simulator. OK, connected. Open Oscilloscope tool, which can capture motion trajectory and speed curve. For this example, there are only 2 axes, no spiral. So, 2 channels are enough. And better to set one big depth. If the depth is too small to capture one complete motion, that is, it is moving actually, but it will not capture following motion anymore. And only their motion distance DPOS are needed. Here, interpolation, so set as XY mode. OK, start the scope. Download the program. It can be seen it is moving. It is drawing one involute arc. Now, it ends. 2.5 circles are completed. Let's try to make it move 3 circles in clockwise. Download again. It is drawing in this way now. And it stops until 3 circles are made. Okay, today's part 1 about interpolation motion knowledge is over. You could use these commands to achieve corresponding motions. And next video, show you how to do look-ahead motion. Thank you for your watching. Also, there is technical article for you. If you are interested in our products, or there are any questions, glad to talk with you. See you next time.